from here, this is not going to happen. The reason why is because once you put in that amine to generate this, the amine actually just reacts with this proton here because it's basic. So this doesn't happen. So it doesn't do the substitution reaction that we talked about. So for the substitution reaction to occur, the nucleophile needs to want to go here, right? Mm-hmm. But instead it deprotonates the hydrogen of the OH. So it's not an effective reaction. Cool. Mm-hmm. And we can't directly get the nitrile from the carboxylic acid. Now, starting from the ester, we can generate the amide. You know how we would generate that?
NH3.
That's right. Yeah. We can also heat here. And we can't directly generate the nitrile, but we can generate another ester here. Let's make this a different color. If we start off with an ester, we can generate another ester. You remember what reaction that would be? If we start off with an ester and we generate another ester.
Transesterification.
Yep. Okay, this is going to be a difficult test to pull off, but I think you get the point, right? What reagent would we use?
ORH.
That's right. Yeah, it can occur in acidic or basic condition. We can do transesterification to regenerate the ester. Now remember that all of these guys can be hydrolyzed back into the carboxylic acid to begin with, right? So if I started off with this nitrile here, right, I can, there's a couple more reactions I should mention with the carboxylic acid. Do you know how we would form an anhydride? See, now we're kind of moving, there's a couple of exceptions. You know how we would form the anhydride with the carboxylic acid?
I forget, we went over it.
Tell us with a P.
Oh, the P. Oh, it's weird. Like P2Cl something? No.
P2O5.
Nope.
It's okay. It's okay. There's a reaction where we can go from the carboxylic acid and form the acid halide.
Is that what
chloride.
the Cl something?
SOCl2.
Yeah.
PCl3. Right now, again, you should kind of have an idea how these reactions, the mechanism of these reactions. Right? You should have an idea of the mechanism of these reactions. These ones are going to have a simpler mechanism because they're not. It's not really an acidic condition per se. So it's going to be more of the reaction mechanism of these guys is going to be more like this, really simple.
Okay.
Not all the protonation, deprotonation. Okay, so if I started off with this nitrile and I wanted to form an acid halide, I would take this nitrile and I would hydrolyze it back into a carboxylic acid using H3, H2O, and acid and heat. Hydrolyze it to a carboxylic acid. Then once I'm here, I can take it to here using SOCl2. And then once I'm here, I can synthesize everything else down here. See that? Mm-hmm. So you can have a synthesis question where they might start you off with one carboxylic acid derivative and ask you to would you make another one, and you would have to have that mental picture as to how you would flow to get there. Does that make sense? Mm-hmm. So if I had well, you start off with an ester, go down, we need some more of this space because we want to make this very comprehensive. We start off with this ester. and we wanted to make an anhydride. What would be your thought process for this?
To go to a
Just do your best. If you can remember it.
carboxylic acid.
Okay.
And then to a acid halide, and then
So we do a hydrolysis. And then we go to what? An acid halide?
yeah.
So that's going to be SOCl2 or PCl3. Right? And then what?
And then you would add the nucleophile.
Perfect. Exactly. That's it. And the reagent for the hydrolysis in this case would be H2O and acid. And then the mechanism for this is, the mechanism for this step here is this right here. This is the mechanism. So if this is the ester, this would be OR, right? And the nucleophile would be H2O. This guy gets protonated, right? We get this, the electron swings up, positive charge. The H2O comes in here, right? So the H2O comes in, then it's going to have a positive charge. Then we're going to deprotonate it using a base. We'll deprotonate it with the conjugate base of the acid. Let's say we had H2SO4, we would use HSO4 minus. Deprotonate this guy, this would now be OH here. So we would have OH, OH, OR here. OR gets protonated. Then we get this, lone pair falls down, kicks out the OR. This will be an OH, right? Then we would form this, use the HSO4 minus, deprotonate this guy, and form this. We would form the carboxylic acid here.
If I were to make a mistake and use those O's and do it that way, do you think I'd get points off?
Probably not much. I think they'll understand the point that you're trying to make. Unless your professor's really petty.
Okay. That makes sense.
Cool. Alright, what if you had nitrile and you wanted to synthesize actually, let's make this a little bit different. So you want to synthesize this. Just see if you can figure out the synthesis steps for this.
Hydrolysis.
Yeah, you can write it out. Yeah.
Should I just write hydrolysis, or do you want me to write?
Write out the reagent, and you can do it step by step if you need to see what's happening.
H2O and acid, and that makes the carboxylic acid. And then you would do carboxylic acid to the acid halide, so that's SO2Cl.
SOCl2.
SOCl2. How do I?
Yeah, with the back you can erase it. Okay, yeah, you can do that too.
SOCl2, and then you would react it with. Is it just like that? Or I know. Oh god. Would it be like HN?
Then you wanna since it's acid halide, you don't really gotta worry about acid and heat because it's really reactive.
Okay.
Cool. And you should be able to have an idea of how to figure out all these mechanisms. Because if it's right? So you can have an idea of how the mechanism would work out. So the main thing you'll be trying to figure out, is it an acidic or basic condition, and then from there you have an idea how to do the mechanism.
Okay, it's so helpful.